Okay, so this is part 2 of sines and cosines. So we're graphing sines and cosines, right? We talked about what the sine curves look like. It starts at 0, goes up to 1, or the amplitude comes back down to 0, down to negative amplitude, back up to 0. That's our general pattern. And then we talked about the process, right? We identify the amplitude, which is the absolute value of A. We identify B, and then 2 pi over B is our period. We multiply that times a fourth, a half, 3/4. Those are our 3 middle points. We plot 0 and the period are the first and last, and our 3 key points in between are those 1/4, 1/2, and 3/4 stops. And then we'd start at 0, we'd go up to 1, come back down, down, and back up again. So we left off with this one, right? We did the A and the B, I think, but we didn't actually graph it. So we're going to go through this whole thing. I'm going to let you try it, like as if this was your warm-up. Graph this all the way through. All right, this was, so it did just say for amplitude and period, but we're going to actually go all the way through. The A is 3, absolute value of that would be 3, so that's the amplitude. B is pi, so the period would be 2 pi over pi, which is just 2. I did a fourth, a half, and 3/4, and you end up, the first key point is 0, the last one is 2, the middle is a half, 1, and 3/2. And we talked about it yesterday, but it doesn't have pi in it, which is fine. It doesn't need to. Some of them are going to have pi in it, and some of them are not. It's not like there's a rule that it has to, okay? Then we start at 0, we go up to 3, we come back down to 0, we go to negative 3, and then we come back up to positive, or to 0.
Do you need the points in between 0 and 3? Or could I just write 3?
That's fine.
Okay.
Yeah. And then if you were, like, we kind of talked about it quickly, I think, yesterday, but what would change if there was a negative in front of this? It flips everything upside down. So I would start at 0, I would go down to negative 3, up to 0, up to positive 3, and then back down again. So a negative reflection works the same as everything else on all the other graphs, okay? It just takes and flips it upside down. So then we talked about the cosine, and we said the only difference is the overall shape. Everything else is exactly the same. Absolute value of A is still my amplitude. B is still 2 pi over B is my period. I would still do a fourth, a half, 3/4. You'd still plot your points. The difference is that cosine starts at the amplitude, comes down to 0, down to negative amplitude, up to 0, and back up to the amplitude. So it has that like valley-ish shape, or that scoop shape, where that would be your cosine. That's the only thing that's different. So now, we didn't do this yesterday, correct? Do this. My advice is to graph it first as though it's a positive 2, and then just flip it at the end, okay? So now do that one. All right, so it should have looked like this. Your A is negative 2, which means it flips it upside down. The amplitude is still the absolute value of that, so it's positive 2. Amplitude will always be positive. The B was 4, because that's what's in between cosine and x, and so the period is 2 pi over 4, pi over 2. Take that, multiply it times a fourth, a half, and 3/4. You get your middle 3 key points. The first one's 0, and the last one's pi over 2. Now, if I did this on an overlap with one that went to 2 pi, this would be 1/4 of it, so it would be really squished. Okay, so if you were to graph this on your graphing utilities, which we're going to figure out today, you would see it as like much more narrow, and it just repeats on the graphing utility. It's not like it stops at the period, so it just keeps going and going and going and going and going, so it would look like a really narrow curve. But everything on your actual drawn graph could look like this. You could space it out. I'm not worried about the spacing as long as it's in the correct order, and you're marking your key points, because that's what I'm going to look for on homework and on the test next Thursday. Questions before we move into phase shift? Okay, so a phase shift is a horizontal shift. That's all that means, okay? AKA horizontal shift. How does a horizontal shift normally show up in an equation? Inside the parentheses. So if you have parentheses and you are adding or subtracting something inside that parentheses, it causes a phase shift, which is a horizontal shift. So the difference here is we figure out what the phase shift is. We take whatever's inside the parentheses and we set it equal to 0, and that's our phase shift. You can also do like C over B, but people confuse the signs, so I would recommend this. Take whatever's in the parentheses, set it equal to 0. If it's positive, you are taking that and adding it on to all the key points. If it's negative, you're taking it, subtracting it from all the key points. So step 1 is still going to be the same. You're still going to find the amplitude in the period. Amp, period. Step 2 is still the same. Period times a fourth times a half times 3/4. But then before you plot these, you have to add or subtract the phase shift from all 5 points. So all 5 key points, God bless you, you're going to then take that and add on your phase shift, or if the phase shift was negative, you're going to subtract from it. Then you plot those on your x-axis, and then you do your curve like you normally do. This is the same for both sine and cosine. So any phase shift is like that. So you see this is an example of a positive phase shift over here. Everything got shifted to the right, whatever that phase shift is. So we're no longer starting at 0, see? You're starting over at the first coordinate point, or first key point, which is going to be shifted off of 0. And then this was sine, obviously, right? We started at 0, went up the amplitude, down, down, down. If it was cosine, you would start at the amplitude here. You'd come down, 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 up, up. But it would be shifted off of the y-axis. So a phase shift is going to cause a shift either to the right of the y-axis or the left of the y-axis. All right, so determine the amplitude, period, and phase shift of the following, and then graph the function. This one tells you there's a phase shift. By the time you get to the test, you're going to have to be able to identify it. So you're looking for parentheses with a plus or minus inside. So A is what? 2, which means my amplitude is 2. B, what's in between the trig function and the x? I circled it. 4 is the B, yeah? Which means the period is 2 pi over 4, which is pi over 2. There is a phase shift, so I'm going to remember it because I have to come back to it. I set this equal to 0. I'd get 4x equals negative pi, and then I'd divide by 4, and x equals negative pi over 4. So my phase shift is to the left because I'm minus pi over 4. Correct. And if you think about it, it's a plus, right? And normally when we do transformations, if it's a plus, we move left. So that should be consistent with what you already know.
Since it's sine, instead of starting at 0, I would start at the...
You're going to start at 0, but on the key point, but I got to find them first.
Okay.
Yeah. So now I'm going to find the key points. So it's originally 0, and then it's pi over 2 times a fourth, pi over 2 times a half, pi over 2 times 3/4, and then the last one is that pi over 2, which is the period. So I first simplify all these. So this would stay 0. This would be pi over 8, This would be pi over 4. This would be 3 pi over 8. And this would be pi over 2. Now, if there was no phase shift, those are my key points. But the phase shift is there, and it's negative pi over 4. So to all 5 key points, I am subtracting pi over 4. So 0 minus pi over 4 is negative pi over 4, that first coordinate point. The first key point should always be your phase shift. This I've got to give a like denominator to, so this would be 2 pi over 8, negative pi over 8. This would be 0, a like denominator here again, 2 pi over 8, and this is pi over 8. A like denominator here, and this is pi over 4. So if it was a positive phase shift, I'd add it to each one. It was a negative phase shift, so I subtract it from each one. Now when I draw my axis, I'm going to pay attention to what points I have. I have 2 coordinate points or 2 key points left of my y-axis, so you just want to make sure you give yourself space on both sides so that you can account for that. So 0 is still a key point. That's in the middle. But then I've got negative pi over 8 and negative pi over 4. So if you work your way down, it would be in order from left to right. And then you've got positive pi over 8, and I've got positive pi over 4. Again, on a normal one, this would be really squished because the whole thing is happening from negative pi over 4 to positive pi over 4. It's really small. God bless you.
Thank you.
My amplitude is 2, so I'm going up 2, and I'm going down 2. Let me make those a little bit more equally spaced. 1, 2, negative 1, negative 2. Now this is sine. Do I start at the amplitude or do I start at the 0? 0, which is here. I go up to the amplitude. I come back down to 0. Negative amplitude, back up to 0.
Why wouldn't, like, the second part? Just kidding, I figured it out.
Okay, I'm so glad I could be helpful. Questions? Determine the amplitude period phase shift of the following and then graph the function. So same process here. My A is what? 1/2, which is my amplitude. B is what? 2. So the period is 2 pi over 2, which is just pi. First key point without the phase shift is 0, and then it's pi times 1/4, pi times 1/2, pi times 3/4, and the last one is that period, which is pi.
How do you rate this?
I don't know. Okay, now there's something in my parentheses, so I know there's a phase shift. I'm going to figure it out by doing 2x minus pi over 2 equals 0. What would you do first?
Move the pi by 2.
Good. And then divide by 2. Good. So this is x equals a positive pi over 4. Now my shift is to the right. Should make sense again because in the parentheses it was minus. So everything,
What would be times 1/2?
because you're dividing by 2, so you can also just write it as multiplied by 1/2. Again, the first key point should be my phase shift, and it is. Then I'd get 2 pi over 4, which we're going to simplify to pi over 2. Change the denominator here, multiply by 2, and I'd get 3 pi over 4. This would be 4 pi over 4, which is pi. God bless you. And this is 5 pi over 4.
Wait, I'm confused.
Where? So this is my first second, third, fourth, and fifth key points. They're all positive this time, so I don't need a lot of space on the left-hand side. My first one is at pi over 4, then pi over 2, then 3 pi over 4, then pi, then 5 pi over 4. Amplitude is only at a half, so I didn't have to go up or down too much either. And again, we have sine, right? So we start at 0, we go up to 1/2, down to 0, down to negative 1/2, and then back up to 0. All right, now what's the trig function? Cosine. So again, at the end, there's going to be 6. They're all going to be grouped in together. So you want to make sure that I've seen it so many times, somebody go through all that work and then graph the wrong one at the end, okay? So just be really, really careful, okay? This is cosine. My A is 2, which is my amplitude. My B is 3, so the period is 2 pi over 3. There's a phase shift. If I set this equal to 0, I get 3x equals pi, and x would be pi over 3. Find your key points. So 0, 2 pi over 3 times a fourth, 2 pi over 3 times a half, 2 pi over 3 times 3/4, and the last one is 2 pi over 3. This stays 0 for now. This would be pi over 6, pi over 3, pi over 2, and 2 pi over 3. Those would be without the phase shift. Then I'm going to add on, because it's positive, the pi over 3. This is pi over 3. First one should always be that phase shift. You'd have to multiply these by 2, so 2 pi over 6, so 3 pi over 6, which is pi over 2. 2 pi over 3. This would be times 3, so 3 pi over 6, and this times 2, so 2 pi over 6, and I get 5 pi over 6. And then this would be 3 pi over 3, which is pi. Again, they're all positive. My amplitude is 2. First one is at pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and pi. God bless you. Amplitude is 2. And it's cosine. So this time I start where? Good. At the amplitude. So I start up here. I come back down. Down one more time. Up and up again. Okay, so the last shift is a vertical shift, okay? And the vertical shift is just like on all your other transformations and equations, is added or subtracted to the function. Now this time it's not in the parentheses. It's usually at the end, but sometimes they trick you and it would be like 2 plus sine of x. That's still a vertical shift. It's not your a, so people confuse that. Be careful, okay? Or it would be like negative 3 plus cosine of x. All it does is cause a vertical shift. So this would be almost the last thing this would be the last thing I would do. Even if there's a vertical, even if there's a reflection, I reflect it first and then shift it. So vertical shift would be the last thing you do. You're going to find A, amplitude, and period. You're going to find 2. You're going to find if there's a phase shift, okay? 3, the times a fourth, a half, 3/4, and then add on the phase shift if there is one. You're going to plot your points. I even connect them to make the graph. And then all the way at the end, you're going to move it up or down if it's a vertical shift. You want it to be the last thing you do. When you start to vertical shift with like cosine, it gets super confusing if you don't plot the original first and then move it, which is why I recommend doing it. Because people will try to add the vertical shift onto the amplitude and it gets really confusing. You flip it and have to do that, it gets even more confusing. So that's why my advice is to graph it all the way through as though it was the answer, but then that vertical shift at the very end, just literally shift all your points up or shift all your points down and then draw your new curve, okay? Yeah. As far as the test question goes, it's literally going to give you the curve, and then it's going to say find amplitude, there's going to be a little space. It's going to say find period, there's a little bit of space. There's going to say find phase shift, there's a little space. It's going to say find the vertical shift, there's a little space. Then you're going to do the work for your key points, then you're going to plot your graph. So that, like, all of that has little parts that add up to the whole overall point. I think it's like 8 or 9 points for a question because there's 3 of them. Yeah.
Is it possible, like, well, not possible, but it's like, for 4x, that you're...
So even though there's parentheses, there's nothing adding or subtracting in there. It's got to be parentheses with an add or subtract. Yeah. So here, obviously, the negative tells me this is going to be upside down at the end. So I write it to remind myself.
That was my question.
Yep.
That means it's reflected, right?
Correct.
So you're saying like
Mm-hmm. Then the absolute value of -2 is 2, and that's my amplitude. The b is 4, so the period is 2 pi over 4, which is pi over 2. There's no phase shift. There is a vertical shift up 1. Oh, I would say vertical shift. If I could spell vertical shift is up 1 at the end, okay? So I go through the motions up until that point. I'm going to take that pi over 2. First step is 0, then it's times a fourth, then it's times a half, then it's times 3/4, and then it's the period at the end. So this would be 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. Those are your 1, 2, 3, 4, 5 key points. They're all positive. My amplitude is -2, but I also have a phase shift. A vertical shift.
so those are your key points.
Correct. There's no phase shift this time. Amplitude is 2. It's cosine, but it is negative cosine, which means I'm going to start at -2, go up to 0, up to 2, down to 0, down to -2. Without my vertical shift, that's what my graph would look like. But the vertical shift is up 1. So all these points get shifted literally up 1. This goes to here, 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 and here.
Oh, you started at 0.
The horizontal starts at 0 because there's no phase shift yet. So then that is your ending curve, okay? You can erase the first one. You can do it in a different color and make it like stand out. I don't care how you do it, okay? On your test, I will even give you colored pencils because you're going to need to do this for both secant and cosecant too. As long as you identify what your ending shift is, that's fine.
If it asks for the amplitude, would it be 2 or 3?
It's 2. Amplitude's 2.
You're gonna go.
Amplitude is just the vertical distance. So this is technically where center is. Whoa, I didn't mean to do that. Hang on. This is technically where the horizontal center is. The amplitude is still 2 in both directions.
And why is it there?
Because it's usually at 0, but we shifted it up 1.
Oh, so it's still 2.
Yep. So that's why it's harder, I think, to move it, especially when you're going to see when we get to secant and cosecant, you need to find those zeros. The vertical shift's the last thing you want to do.
So wait.
So A is what?
2.
2, which is my amplitude. B, 3. So the period is 2 pi over 3. Is there a phase shift?
Yes.
No. There's nothing added or subtracted inside the parentheses. Is there a vertical shift? What is it?
Down one.
Down one. Good. So now I'm going to do the 2 pi over 3, 0, 2 pi over 3 times a fourth times a half, and then 2 pi over 3. Okay. This is pi over 6, pi over 3, pi over 2, and then the last one is the period, which is 2 pi over 3. We go to the graph. Zero, pi over 6, pi over 3, pi over 2, 2 pi over 3, amplitude is 2. It's cosine, so it starts where? Amplitude. Good. At the amplitude, it's positive cosine 2, so it's positive amplitude. This would be my original curve. And then my vertical shift says, take all those points and shift it down 1.
So can you do that? Can you do the dots?
Yeah. Raise your hand if you got it right. Okay, good. Questions before we jump into the calculator? You say no? All right, so you're riding a Ferris wheel. Your height h in feet above the ground at any time t in seconds can be modeled by 25 sine pi over 15 times t minus 75 plus 30. The Ferris wheel turns for 135 seconds before it stops to let the first passenger off. Use a graphing utility to graph the model, and then what are the minimum and maximum heights above the ground? So we are going to type this into the calculator. I'm going to type this all the way into the calculator. I'm going to type 25 sine. It opens the parentheses for me. I have to do pi divided by 15. Close the parentheses. Open the parentheses again. Oh, no. Sorry, this is all in one. Pi divided by 15. And then t. T is just your variable, so you can use x. Minus 75. Yeah, because you want them both to be there. Plus 30. I'm typing it in.
So 25 sine parentheses?
25 sine will open its parentheses, but then open the parentheses again to get that pi over 15, because you don't want the order of operations to take over and find the sine of that first. It should be underneath the... What do you mean you got 30?
Like that was the answer?
No, we're supposed to put it up.
Oh, no, then you gotta...
Yeah.
Now we gotta graph it.
Yeah.
No!
I know. Wait.
I did it wrong.
Wait. The parentheses?
No, the plus 30 is outside the parentheses, because the plus 30 is a vertical shift.
Sorry, so like I closed both parentheses, like the whole parentheses.
So first of all, what mode do we have to be in? Radians. Secondly, what is happening here? Why do we think this is like this? Think about what's happening on my, look at my amplitude's 25, so it's going up 25, down 25, and then there's a plus 30 that literally took that and shifted all the way up. Does that make sense?
What does the x minus 75 do?
That's just, that would be a phase shift if you distributed the pi over 15 in. You'd have to do that. So if you were to actually find this and graph it, which those numbers would not be so ridiculous, you'd have to distribute that in. Are you on radians and your zoom might be different? Your zoom might be completely different, that's all. So I'm going to do it on the app because it's so much easier to zoom out on the app. But just know that you can. Okay, so think about how you could have understood your graph before you even knew to pinch and zoom out, right? First of all, it says the Ferris wheel, blah, blah, blah. It says use the graphing utility to graph the model. We did that. What are the maximum and minimum heights above the ground? What if you didn't have a graphing utility? What would that look like on an actual hand, like if you had hand-drawn your graphs? How would you know the maximum and how would you know the minimum? The amplitude, now with a vertical shift, you're going to take that amplitude and you're going to do what with that vertical shift if I want to know the max? Add it. And if I wanted to know the min,
You take the negative and then
good. You take the negative and then add it. So you take them. So if I thought about what this really looked like, this would be, let's say it goes here, right? This would be 25. This would be negative 25. And then I would have shifted up 30 and shifted up 30. So my max height is at 55, which I'll show you how to get from the calculator too. The minimum height is negative 25 plus 30, so that's 5. You're not going to subtract the vertical shift off of it because you're taking that minimum and you're pushing it up, okay? But on your graphing utility, if you double tap your home screen or on your, like over here, you'd have to mess with your window a lot. But you'd be able to double tap your home screen and then find this coordinate point and find this coordinate point, and the y coordinate of them would be your max and your min. Does that make sense? Okay, so you're going to get some sort of equation in which there's some sort of application. Just kind of understand what you're reading based on your equation. You could have done that without a graphing utility, but it did tell you to graph it on the graphing utility and then do that. There are 2 word problems at the end of the homework. You are going to use the graphing utility. You're going to take the picture of the graphing utility and then answer the questions based on that. The rest of your homework are all hand-drawn graphs. You can use a graphing utility to check your graphs, but realize it's really hard because you'd have to restrict your window in order for it to match perfectly. So if I wanted to know what like y equals 2 sine of x looks like, and I only want 1 period, I'm going to type that into my y equals part, but then I'm going to restrict it to my 1 period, and period is 2 pi. So I would restrict my x from 0 to the max 2 pi. And then when you do your graph, it will give you the exact, it will cut it off from here to here. It will give you the exact period, okay? But you literally type this in, right? And then you go to window, and the x min is 0, and the x max is 2 pi. And then it will take and give you your window of just that frame instead of the repeat, repeat, repeat. The y doesn't matter because it's not going to go up or down. It's still the same vertical shift, right? Yeah, only if it's a huge vertical shift would you have to cause your window to change y, like the example with the word problem. All right, there's also, real quick, on the module underneath chapter 4, there's some stuff there that if you're curious, like how you want to, don't refresh. Yeah, okay. Scrolling. Carefully, because otherwise it moves it. This FET trig simulator, it's underneath the warm-up for 4-5, is just the overlap of your unit circle with your curve. So yesterday we kind of talked about like where does it come from. The top is your unit circle, and as you move around, the dot's going to move on your curve. So it's just kind of like the application of the two. If you're one of those people that likes to understand the curve, feel free to go there and investigate a little bit. But basically, if I did sine, cosine, or tangent, which we'll get to on Friday, okay, I can do the labels and I can do my special angles, and it's going to give me those. I could switch it to radians. And then there's my parent function of cosine. As you move around your unit circle, as I go from pi over 6 to pi over 4 to pi over 3 to pi over 2, that little dot moves around your unit circle. I've already gone around once, so it's doing coterminals. That's why it keeps going. If I come back, there's the first full cycle. So like the very first point is here at 1, and then it would go to a half, and then it would go to, it would go to root 3 over 2. And then root 2 over 2, and then a half, and then it would be at 1. So that kind of just like goes through the motions of that trig function. Sine and cosine are both there. We're eventually going to get to tangent, and then we'll get to cosecant and secant. All that stuff's on Friday. But if you're like that type of person that like just likes to, understand where those points come from, this is how you could do that.